Hello and welcome back to my channel. In today's video, I'm going to be walking you through some basic chemistry calculations. So if you are in high school and you're struggling with some of the foundational calculations in chemistry, this video is for you. Okay, so the first question I have is on mole and molar mass. And the question says, how many moles are in 25 grams of sodium hydroxide? If you use the triangle method, we have the mass here, the number of moles here, and then you have the molar mass. Now, the triangle method relates mass, moles, and molar mass. And in order to find the mole, your formula is going to be N, so mole is N. N equals the mass over the molar mass, which means I need to find the molar mass. I have the mass, which is 25 grams, but I don't have the molar mass. So to calculate the molar mass of sodium hydroxide, sodium, you have just one. Multiply that by the mass of sodium in the periodic table, which is 22.99. Now that gives us 22.99 as well. Now oxygen, you have only one. Multiply by 16 grams of oxygen in the periodic table, and that gives us 16. The last one, hydrogen, you have only one as well. Multiply by the mass of hydrogen in the periodic table. So if we add all this up, that gives us molar mass. So this is going to be 39.998 grams per mole. So now we have the molar mass. The next thing we do is plug the mass and the molar mass we just calculated into this equation. So our moles, N, is going to be equal to 25 grams that was given, divided by the 39.998 grams per mole of the molar mass. And that gives us 0.63 moles of sodium hydroxide approximately. The second question I have is on stoichiometry. The question says hydrogen gas reacts with oxygen to form water. So we're going to go ahead and draw out our equation. So H2 gas reacts with O2 gas to give us H2O. Now we're going to go ahead and balance this equation. Sometimes they give it to you and you balance it. Sometimes they give you the balanced equation as well. So this is a case where you have to write the equation yourself. So now we're going to go ahead and balance. I have two hydrogens here. This is 2, so we're good. Now this is 2 oxygen. Over here you have only 1. So go ahead and add 2 in front of this molecule. And that gives us 2 oxygen. So the addition of 2 in front of the H2O changes the quantity of hydrogen. So now it is 2 times 2, 4 hydrogen atoms. So I'm going to go ahead and add 2 in front of this hydrogen as well. And that balances my equation. So before we do any stoichiometry calculation, we have to make sure that the equation given to us is balanced. And even if you are not given an equation, you have to write out the chemical equations, balance it before you solve. So this question says, if you have 4 moles of hydrogen, how many moles of H2O can be produced? So we're going to start with the 4 moles given to us. So you say 4 moles of H2. This is where you make use of your chemical equation. So the mole ratio of H2O and hydrogen is 2:2 ratio. So I'm going to go ahead and say 2 moles of the H2O. This is what we're trying to find. So that is your priority and you place it on top. Now divide this by the 2 moles of hydrogen. You're comparing those 2 ratios. So once you have that written, you're also going to make sure that these 2 moles of hydrogen are on opposite sides. So they cancel out and you have the mole of H2O remaining. So our final answer will still be 4 moles of H2O. And the reason this is like this is because the ratios are the same. So you have 2:2, which is the same as 1:1. So whatever hydrogen you have in moles is going to be the same moles for water because they are equal. Okay. And that is it. The other question I have is on percent composition. So you're asked to calculate the percent composition of carbon in glucose. So we're going to look at the formula of glucose and go ahead and calculate the molar mass. So starting with carbon, there are 6 of them. Multiply that by 12.01 mass of carbon in the periodic table. That gives us 72.06. Now hydrogen is 12 multiplied by the mass of hydrogen, which is 1.008. So 12 times 1.008 gives 12.096. Now oxygen, you have 6 multiplied by 16. That gives us 96. Now we add them up. So 72.06 plus 12.096 plus 96 gives 180.156 grams per mole. That is the molar mass of glucose. So to find the percent composition of carbon, we're going to make use of this formula. So percent composition is equal to mass of element over the molar mass of the compound times 100. Okay, so in this case, the percent carbon would then be equal to the mass of carbon, the total mass in that compound, not just the atomic mass in the periodic table, but the total mass. You've included the total number of carbon, which is 6 in that calculation. So that would be 72.06 over this total mass, or the molar mass, 180.156 times 100. So if we plug this into the calculator, we have 72.06 divided by 180.15 and then times 100. So the percent composition of carbon would be 40% approximately. So I rounded this up. It's 39.998. So I rounded it up to 40%. So that's how you calculate percent composition. And you can do the same thing for hydrogen. You can do the same for oxygen. All you have to do is use the mass of oxygen, plug it into that equation, and solve. Same with oxygen. Use the mass of hydrogen, plug it into the equation, and solve. You do the same for oxygen. The mass of oxygen over the total mass, or the molar mass, times 100. And that gives you the percent of each element. So you can try that one out and make sure that after your calculation, they will all equal 100%. Okay. The next is on concentration or molarity. The question says, what is the molarity of a solution containing 10 grams of sodium chloride dissolved in 500 ml of water? Now we're going to start with the formula of molarity, or molar concentration. So molarity, which is also written as big letter M, okay, so it's the same thing, is equal to the number of moles of solute. We would just say N, the number of moles of solute over the volume in liters. The volume has to be in liters. So the unit for molar mass is moles per liter. This is another way you can remember the formula. So now we need the moles, we need the volume in liters. So they gave us 10 grams. That is not moles. So we're going to first convert the 10 grams to moles. So remember, from the triangle method, N is equal to mass over molar mass. So we have the mass, which is the 10 grams, but we don't have the molar mass. And to find molar mass, we would use the sodium chloride, because they said 10 grams of sodium chloride. So starting with sodium, we have only one sodium, which is 22.99 times 1. It's going to give us the same thing. Now chlorine, only one as well, which is 35.45. So together, this gives 58.44 grams per mole. Now go ahead and divide the 10 grams by 58.44 grams per mole. Now, when you divide, this gives us 0.171 mole. So we have our N. The next thing we do is to find the volume in liters. They gave us the volume in milliliters. Recall that 1,000 milliliters makes 1 liter. So 500 mils times 1 liter on top. 1,000 mils makes 1 liter. So 1 liter on top, because that's our priority now. You want to find that, and then divide by the 1,000 mils. So the mLs we cancel, and you have 0.500 liters. Now back to this equation, molarity, capital M, equals the N, this is our N, remember? So the N that we found earlier, 0.171 moles, then divide that by the 0.500 liters, and that would end up giving us 0.342 moles per liter. Now remember, you can also write that as 0.342 molarity, big letter M. Now the next question is on gas law, precisely ideal gas law. The question says a sample of nitrogen gas has a volume of 2 liters at a pressure of 1 atm and a temperature of 273 Kelvin. How many moles of nitrogen are present? So we have to identify the parameters given to us. We have the volume, V, we have the temperature, and then pressure is P. And the question is how many moles, which is N. So in ideal gas law, P, V, T, and N will be present. None of them is constant. Okay? And that's how you know that this is ideal gas law. In other laws, you are going to be seeing initial values and final values of some sort. But in this case, you just have each one value given to you with one unknown. So ideal gas law is PV equals nRT. The unknown value is N. To make this easy, rearrange this formula to find N. So you would divide both sides by the arrow T. That way the arrow T's will cancel out, and your formula now is N equals PV over arrow T. So what we would do at this point is plug in the values as we see it here. So I'm going to write it down here. So we have P, which is 1 atm. Volume is 2 liters. Divide by arrow is what we call universal gas constant. And the value we would use here is the one that has liters and atm, which is the 0.0821 liters.atm / Kelvin.mole. Okay. There are other values. There are some in kPa, which will be 8.314 and so on. But this is a common one when you have atm. So I'm going to use that here, 0.0821 liters.atm / Kelvin.mole. And then multiply by temperature, which is 273 Kelvin. Now, the next thing I like doing here is cancel out the units. This is important because sometimes you forget the units of what they're asking you. But when you cancel out the units properly, you'll be able to remember the units of the unknown. So the ATMs on opposite side cancels, the liters will cancel, the Kelvin will cancel, and that leaves us with mole, and that is our unit, okay? So we're just gonna go ahead and multiply the numerator. So we have 1 times 2, which is 2, divide by, then you have the 0.0821 times 273, and that's gonna give 22.4133. Now divide, 2 divided by 22.4133, it gives me 0.089 approximately. So 89 moles of nitrogen. Okay, so the next question is on limiting reactants. Now, the question says magnesium reacts with hydrochloric acid, and that's the equation. So if you mix 3 grams of magnesium and 10 grams of HCl, which is the limiting reactant? Now, I have my own method of solving this, and I find it much easier and straightforward. So I'm going to be using that method for you. So the idea is you're going to use each of these values separately to solve for the moles of any of the products. Okay, so I'm going to choose hydrogen because that's much easier to go about. So what we would do is go ahead and solve for the mole of hydrogen using 3 grams of magnesium and 10 grams of HCl. The reactant that gives you the smallest mole becomes your limiting reactant, and the one that gives you a larger mole becomes your excess reactant. Okay, so we're going to go ahead and start. So 3 grams of Mg. So the first thing you do in stoichiometry like this, where your starting value is in grams, is converted to moles. Or even if it's in any other units, once it's not moles, you have to first convert to moles before you do your calculations. To convert grams to moles, we need the mass of magnesium. So magnesium is 24.31 grams per mole. Now, that mole is our priority. So place the mole on top. So mole magnesium on top and the grams as the denominator. This is very important in your arrangements. So the gram magnesium would cancel out grams magnesium because they are on opposite side. Now we have the mole of magnesium. So go ahead now and compare the mole of magnesium with the mole of hydrogen. If there was no specific product, sometimes they combine these questions with the mass of one of the products. If you have a question that combines the mass of one of the products, just go ahead and solve for that product in your question. But in this case, you can choose, so I choose hydrogen. So 1 mole of hydrogen on top against 1 mole of the magnesium. So this is a 1-to-1 mole ratio situation. So this mole of magnesium will cancel, and we're going to stop here because the question is just asking for limiting reactant. So this will mean that I'm going to do 3 times 1 times 1 divide by 24.31 times 1. And that gives me 0.123 mole of hydrogen. So that's the first calculation. Now we're going to do the same thing with the HCl, the 10 grams of HCl. So starting with 10 grams HCl, again, we're going to have to find the molar mass of HCl. In order to convert to moles, you need the molar mass, okay? Remember your triangle method. So we're going to go ahead and find the molar mass of HCl. Hydrogen is 1.008. Chlorine is 35.45. So if you add those two together, you will have 36.458 grams per mole. Now, as usual, the mole is our priority because we're trying to convert to moles. So the mole stays on top, mole of HCl, and the 36.458 grams of HCl will be the denominator. Now, go ahead and cancel out the HCls, the grams of HCls. Now we have the moles of HCl. The next step would be to also do the same comparison. Remember, if you choose hydrogen, stick to hydrogen. If you choose the MgCl2, you stick to that as well. So I'm going to convert to 1 mole of H2, okay, and then divide by, this is 2 moles. So 2 moles of HCl. So HCl and hydrogen are 2-to-1 ratio. The hydrogen is what we're trying to find. That's our priority. That stays on top. And then the HCl, you divide by that. So the more HCls we cancel out, and we have, again, the mole of hydrogen. So 10 times 1 times 1 gives us 10. Then divide that by 36.45 times 2, and that gives us a 0.137 mole of H2. So the question you ask yourself next is, between these 2 moles, which is the smaller mole? The smaller mole would be this one. Okay, so 0.123 is smaller than 0.137. So we're going to trace back to the beginning what reactants gave us that smaller mole, and that's magnesium. So your answer would be that magnesium is the limiting reactant. So we'll just say LR. Okay, and that is it. So we move on to the next one, energy changes in reactions. The reaction is given, and the question says the reaction releases 890 kilojoules per mole of carbon of CH4 burned. Now, how much energy is released when 0.5 moles of CH4 reacts? The enthalpy of reaction was given, that is 890 kilojoules per mole. Now, when they say release means it's exothermic. So this is going to be negative 890 kilojoules per mole. So we have the enthalpy of reaction, and the question is how much heat is released. So we need to find what we call enthalpy change, delta H. Now, it might be confusing. These two are actually different. This is enthalpy of reaction. This is change in enthalpy. So we're to find change in enthalpy. And they also gave us the value of N to be 0. So this is 0.5 mole. So the equation that connects two of them is this. Delta H of reaction, I'm just going to say R, this first one, is equal to enthalpy change divided by N. So enthalpy change is in kilojoules, N is moles. That's why you see the kilojoules per mole, okay? To find this enthalpy change, you're going to cross multiply, and the equation we will be using is delta H equals the enthalpy of reaction times N, which gives us, so I'm going to continue from up here, okay? So that gives us delta H equals negative 890 kilojoules per mole times the N value, which is the 0.5 mole. These two moles we end up cancelling. When the moles cancels, we have our kilojoules. And that will give negative 445 kilojoules as the heat released or the energy released. Again, in negative. How much energy is released? That's the question. So you can go ahead and say 445 kilojoules of energy released. If you want to like write it in words, okay, is released or released. And that's it. The last question I have is on empirical formula. So this question says, a compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen by mass. Find the empirical formula. The first thing we do is assume 100 grams, okay? Which simply means you're going to go ahead and do carbon equals 40 grams instead of the percent. And then hydrogen is 6.7 grams and oxygen is 53.3 grams. So we're changing all of these percentages to grams when you assume 100 grams. So that means that if you add everything here, it's going to be equal to 100. So we're good with that. The next thing we do, for each of these grams, we divide by the masses of these elements. So the mass of carbon is 12.01. Divide this 40 by that, and this gives me 3.33. Then for this one, divide by the mass of hydrogen, and that would be 6.65. Then this one, divide by the mass of oxygen, and that would be 3.33. Next step, once you calculate so what we just calculated are the moles, okay? Because you're dividing by their molar masses. So this is grams per mole. That's also grams per mole. And this is grams per mole. So I just need to show you this quickly. So this gives us moles. That's just what we did. Remember, when you use the triangle method, number of moles is equal to mass over molar mass. So that's practically what we do the first time. You find the moles of each element. So now the next thing we do is divide by the smallest mole. So carbon and oxygen happen to have the same amount of mole, and they are both the smallest compared to 6.65. So we're going to divide all through by 3.33. This gives 1. 3.33 for this one as well. That gives us 2. And then this one as well. And this gives us 1. So this simply means that the molar mass of that compound is 1 carbon. So 1 carbon, we usually don't show the 1, okay? Because while looking at the carbon, you can see it's 1. Then 2 hydrogens and 1 oxygen. And that's it. So this is your empirical formula. I hope you found this video helpful, and don't forget to subscribe to my channel if you're not subscribed yet. And thank you so much for watching, and do have a wonderful day. I will see you in my next video. Bye.